Alright, so now we wrote this out. So carbon gives you what product for CO2?
36.68.
Okay, 36, right? 36.6 grams of carbon dioxide. Now, I need to figure out how much product that oxygen is going to give if this is a limiting reaction. So I'm going to go ahead, do the same thing. Okay, so I'm going to keep most of it in, but I'm just going to rewrite it. So here I'm starting with 26.6 grams of O2. That gives me 32, right? 32 grams of O2 for every 1 mole of O2. For every 1 mole of O2, I have 1 mole of carbon dioxide. For 1 mole of carbon dioxide, I have 44.01 grams of CO2. Do the math, what do you get? 36.58 grams. This gave you what initially? 6.8 grams. So which one is the limiting reactant? O2. So O2 is a limiting reactant. Therefore, your theoretical yield is going to be 36.58 grams.
Wait, isn't it over? Isn't approximate that? The exact.
What is how many moles of oxygen?
Is it theoretical?
Wait, what's the answer to that one?
Theoretical yield is what you're supposed to get if everything goes perfectly. Now, but if I say, I want you to tell me what the percent yield is if the actual was, 20 grams. So all you will do is put actual over theoretical, and that's going to be 36.58 grams multiplied by 100. That tells you, hey, you were supposed to get 36.58 grams, but you only got 20%. So what is your percent yield? It's going to be what, like 54.6. Okay, good. You're looking for percent yield, that's what you do. Give me a second. You're assuming that hydrocarbon only has C and H, right? And that it's going through a combustion reactor. So, in the guided notes section, when we did this in class, I told you that the basic combustion reaction formula is something like C with however many carbon with the however many hydrogen combined with O2, giving you H2O and CO2. Okay, and just like in the notes, we assume that all the carbons come from the hydrocarbon and that all of H's come from the hydrocarbon. So, CO2. So hydrocarbon burns completely. It's got 7.2 grams of water, and it gives you 7.2 liters. And it's asking for what is the empirical formula. So, just like the guided notes, right? Assume all of the hydrogen, assume all the carbon come from that. So, that gives me a way to do this. When I know the first instinct is that I got to put everything in moles, because moles is the language, right, of the reaction. So I'm going to go ahead and put water into the moles, and I have 18 grams of water for every 1 mole. Now, I'm looking for hydrogen only. So I'm going to assume that for every 1 mole of H2O, I have 2 moles of H2. Whatever this is going to be the number of moles that I have in the hydrocarbon. That's all hydrogen, right? Because think about it. All of this hydrogen comes straight from this hydrocarbon. Same thing happens with carbon. All of this carbon comes straight from the hydrocarbon. For every 1 mole of H2O, I have 2 hydrogens, so it's 2 moles of hydrogen. When I do the math, I get 0.8 moles of H total. Now, carbon dioxide. Cool thing about this is that they told you that this is ASTP, so I can assume that for every 1 mole of any gas there is, I can assume 22.4 liters. So if I have 7.2 liters of carbon dioxide, for every 1 mole of carbon dioxide, I have 22.4 liters. Now I'm just going to look for the mole of carbon in the carbon dioxide, which is just 1, right? So for every 1 mole of carbon dioxide, I have 1 mole of carbon. I do the math and I get 0.32 moles of carbon. Because H2O has 2 hydrogen, there are 2 moles of hydrogen in 1 mole of water. Okay, so I have in this whole thing 0.8 moles of hydrogen and 0.32 moles of carbon. Now, this is just like empirical formula. What is my next step if I found that there's 0.8 moles of hydrogen and 0.32 moles of carbon?
Each by the smallest.
So I'm going to divide each one by 0.32, right? And I get the ratio that is 1 and 2.5. Multiply by what? 2. When I multiply by 2, I get C2H5.
And that's
That's the empirical formula.
That is empirical formula. Did they ask for a molecular formula?